Okay, everybody, welcome back. Our next subject is on firepower, high availability, really high availability and clustering, and how to enable and then examine the two technologies. I like to keep this real simple whenever possible. In our industry, we have simply too much to keep in mind to have to individually memorize every single subject. So here's what I mean by keeping it as simple as possible whenever possible. If you are familiar with clustering and failover on the ASA side of the firewall appliances, then you're going to be real happy because, again, firepower threat defense inherits the failover and clustering options of the ASA. So what that means is on the next couple slides, first keep in mind the differences. We have our failover two appliances that, if you will, are mirrored between each other, and one being in active, the other one being in standby. And then also our clustering, in some conditions, the ability to scale up to 16 devices. So as we go deeper still, please keep those in mind, whether it's going to be within the same chassis, intra-chassis, between chassis, inter-chassis. Again, keep in mind the differences between, for now, failover and clustering. So without further ado, failover versus clustering. If you ask me, the key difference is going to be in what features are supported, and then also the scalability that's available between these two options. Please understand, folks, in failover, whether I'm doing this between a physical firewall or between what's referred to as security context, which is really a virtual firewall, what we ultimately have is one firewall that is in active state and the other firewall that is in a standby state. So once again, we have an active standby pairing. As a matter of fact, you actually have the ability to do active pairing with the use of your virtual firewall as your security context. But bottom line is, in my sarcasm, the way I like to explain it best is one firewall is doing all the work, while the other firewall, you still got to pay for it, you still got to rack, stack, and deploy it. It's still collecting a paycheck, but it's doing none of the work. While again, over here under the clustering category, you can scale one more time up to 16 devices, depending upon your configuration, your appliance type, your features. But again, scale up to 16 devices, and they're able to work again as a cluster, and we can distribute the load between those physical devices. Now let me pause. We're going to go deeper, I promise. We're just getting started here in this presentation and this topic. So we're going to go into some of the real-world recommendations when you're doing clustering. So stay tuned. Until then, let's get into a little bit deeper. Please note what's happening here on this slide. It can be a pretty busy slide. The first thing they're talking about is your software, your operating system, whether it's again going to be the ASA operating system or firepower threat defense, which, let me pause for a moment. Remember, firepower threat defense can run on an ASA or a firepower appliance. Hopefully, if we pause for just one moment, hopefully in the topics presented so far, we've made that clear to you that we have images and then again our platforms, if you will. Images and then platforms. Now we're getting into something even newer, which again is going to be one of the many features that we're going to be talking about. Let me learn how to spell features properly. One of the many features that we're going to be talking about, which is again failover versus clustering. So let's go a little bit deeper. Again, failover, one more time, allows us to do active standby. So whether that's again going to be two appliances, physical, for example, ASAs, or again modules depending upon the form factor, maybe for example one of the larger ASAs. Please note again our active one more time, but I want to be very clear that takes us back to what we talked about just a moment ago with the security context. And one more time, a security context is a virtual firewall. So let me pause here just for one moment. I'm really glad that the book is going over this again and again because it gives me a chance to go deeper every time. This security context, especially using the term virtual firewall, is not to be confused with a firewall as a virtual machine. So this is not an ASAV, for example. This is literally one physical firewall, And on that physical firewall, we're creating multiple virtual firewalls, what's officially known as a security context. And then we'll do the exact same on the other physical firewall. We'll create a mirror of the virtual firewalls or the security context. And then from there, we're able to pair the security context virtual firewalls of this physical firewall with the security context virtual firewalls of this physical firewall, so they can then run in an active-active failover relationship. And for those of you who are really keeping count, I wonder how many times did I say physical firewall versus virtual firewall? Of course, that's sarcasm. Let's move on. So again, notice here with the Firepower Threat Defense software, again running on our 5500 series X appliances. Remember, again, we can do our active standby one more time between modules depending upon the, let's say, for example, ASA model that you have, or between two actual physical appliances. Now let's come over here in the clustering of our Firepower series, the 9300s and the 4100s. My favorite feature here is absolute scalability, because if you take a look at this real close, we can do intra-chassis, depending upon our model, within inside of the same Firepower appliance, less than or equal to 3 modules. And that's again going to give us some pretty serious throughput. Or again, guys, we can do between appliances, between inter-chassis, as we said earlier, less than or equal to 16 appliances. So please note, same idea here for inter-chassis on the 4100 series. So please, if you will, notice the difference. There is no intra-chassis on clustering of the 4100 series on this review right here. But again, if we come on down here with the Firepower Threat Defense software on the 9300, we're able to do, again, intra-chassis with less than or equal to 3 modules within the same chassis, intra-chassis. And we're able to do inter-chassis less than or equal to 6 chassis, or again, 6 Firepower appliances. So folks, this is giving you some incredible resiliency, but especially when you look at these numbers, it's giving you some pretty serious scale of your throughput. All right, so now we're going a little bit deeper here, again, whether it is ASA or Firepower Threat Defense, but configuring failover. So I want to keep this real simple, because again, there's a lot of bulleted items that are saying the same thing that we're going to say simply. The 2 appliances need to be identical. Identical in modules, identical in their licensing, identical in their interface config, identical even in the virtual addresses, virtual IP and virtual MAC, that they're servicing out to our clients. Because we have to keep in mind very, very seriously, and we're going to go over this inside of the GUI coming up in a moment, but these 2 physical appliances are servicing a virtual IP and a virtual MAC, guys, for one very, very simple reason. And that's, again, end devices, they have ARP caches, and in the ARP cache, they're going to have an IP and a MAC address association. So we need to make sure that no matter which device is actually servicing the packets, maybe it's the secondary that is now active mode, we need to make sure that it is still servicing that same virtual IP address and virtual MAC address, so all of those entries in the ARP cache are still valid entries. Now also, please keep in mind, this failover delivers high availability, resiliency to a failure in a single device, but once again, no scalability. And that is no scalability when we compare it to something like clustering. Don't get me wrong, even though on one hand, failover is limited to 2 physical appliances, we still in some situations have an active approach with, once again, multiple security contexts that do give us an added degree of scalability. But the simple reason why this slide is saying no scalability is because we're comparing it to clustering, which is coming up right now. So once again, what perfect timing. Clustering up to 16 security appliances. Now be careful though, let me pause. They say appliances or modules combination. Guys, I really don't want to take us all the way back to that slide a couple of moments ago, but just reference back, if needed, in the differences between inter-chassis and intra-chassis. Between chassis and within the same chassis. So once again, the highest number that's possible is going to be inter-chassis, with up to 16 parallel devices. So I totally agree with what the slide is saying here, which is not only high availability, so resiliency and recoverability from a failure, but also scalability. And as we said earlier, as we got deeper into this, we're going to give you a little bit more real world information. Please understand, let's say we have our servers down here, let's say a destination, and we have a client over here. What we want to do in order to take best advantage of this clustering is we want to verify, we want to make sure that the load mechanism, per the documentation and per the book, they call it a load balancing mechanism. But guys, as you dig deeper into it, the reality is it's a load distribution mechanism. There really is no true balancing between the physical links or between the physical appliances. Again, if you're going to go take the test, you say load balancing. Once you've passed the exam, you know we say load distribution. But once again, the load balancing mechanism that you use in a setup like this, you need to make sure that you mirror it as the same load balancing mechanism between all of the devices along the way. So for example, let's say that these are Nexus devices, and Isaac, why did you say Nexus devices? Well, simply because they're giving us an example of a VPC. Well, by default, this uses source destination IP, and that's really, really good because, for example, the ASA would also use source destination IP as its default load balancing or load distribution mechanism. Folks, let me say this another way. The last thing we would want, really for an interesting reason if you ask me, and I'll explain that reason in a moment, but the last thing we would want is to have a different load distribution mechanism every step of the way, and this poor packet getting dizzy in the way that it's traversing, it's traveling through our different appliances. Now let me pause for a moment and go back. Why did I say a moment ago that something like that would be a worst case scenario, the last thing you want? Isaac, I don't understand. Why is that the last thing I ever want? It looks like it's working. Well, there have been times where I've been in scenarios where the load distribution mechanism was not the same, and as I just illustrated, the packet was a very well-traveled packet, and we never knew it for 6-8 months. Not until we had latency issues that we realized, oh, it had been working all this time, but it was taking a very dizzying path to get from source to destination. So there are some times when I would rather things just to flat out fail, and I have to dig deeper and figure out what the problem is and tune it ideally for my needs, versus have something working for months on end and not know until I tie it together with some other problem that I'm troubleshooting. All right, anyways, continuing on. So as far as the clustering requirements, folks, one more time, you know how much I love to repeat myself. Seriously, it's a great way for learning. Up to 16 identical appliances. But be careful, 16 is just the number, the maximum number of, again, inter-chassis. The number of total modules is going to be based upon the firepower appliance that you go with. And then also notice the firepower with threat defense scales up to 6 identical appliances or modules. So just be careful with what operating system, as we remember from that table earlier, what operating system, and then also what model number that you're going with. All right, inter-chassis clustering. So please note what we're doing here is we're going over some of the requirements. Again, on the 9300 series, the intra-chassis prior to version 6.2, our inter-chassis, please be careful with that little preamble on that word. Again, it's going to be our FXOS 2.1.1 and Firepower Threat Defense 6.2 or higher. So we're literally mentioning, hey, if you want to do this option or that option, these are going to be your OS restrictions, your minimums or maximums. And then notice again, if you're doing your next-gen firewalls, all of the appliances in that cluster need to be identical. And not only that, which by the way, we've mentioned the word identical a number of times, but not only that is if you're on the 9300s, up to 5 chassis identical, just to throw that word out there one more time. On the 4100s, again, up to 6 chassis, you know it, identical. So now we're getting into the configuration out of the weeds of the theory and into the actual configuration. So notice here under devices, device management, and we can see our cluster, the name that we gave it, and then far, far more important, the individual devices that are inside of that cluster. And give us a couple minutes, we'll go over these little states, these current conditions of the physical devices. Folks, we're also able to go in and delete and manage the cluster, which we're going to be doing starting right now. So the actual configuration, please note we're adding a high availability pair. So if I can back up for just one moment, we're able to go in and add from this main screen here, giving it a name, the types of devices, you know it, that have to be identical in this pair. And then folks, we're defining a primary peer and a secondary peer. Let me pause for one moment because I kind of threw that term out there a little bit earlier. And now that we see it for a second time, I really do want to explain it in greater detail. Understand that just in my example, we're talking about the ASAs. Again, for example, there is a primary and a secondary. So this is going to be the device type, if you will, or you could even say the role. Then by default, I want to be very clear, the primary is active. That's again going to be more of a device state. And the secondary is going to be standby. So please keep clear that there's absolutely nothing wrong under normal circumstances, again the primary being active, but folks, under a failure circumstance where the secondary could be active, the primary could be standby and the secondary can be active. So please be careful because this term, primary and secondary, you're going to see a couple of times. How about this? We click on continue, go over here to our second step, and then notice what this interface is simply telling us, a couple of things. I'm going to kind of come down here real quick, is when you are primary, you're going to be this IP. When you are secondary, you're going to be this IP. So one more time, when your role is of a certain type, you're going to be using this particular IP. And then guys, let me back up a little bit, going over the actual interface where we are, again, linking the two appliances together. And then if we, or excuse me, in my opinion, because I think this is something we should be doing, so when we enable stateful failover, we can either use the same interface or even dedicate, depending upon the amount of state information that needs to get replicated. If we're in a high load on replication, we might want to dedicate a different interface. And then guys, last but not least, if we wanted, we can even encrypt all the communication that is being replicated and communicated between these two firewall appliances. This again might be determined by any kinds of regulations or any kinds of compliances that you might encounter in your environment. So there we go. We have, again, a new HA pair configured. Here are the two physical devices, and as we said a moment ago, the states of those particular devices. So if we were to go a little bit deeper, we could see on those two devices, we have these following interfaces, and these interfaces are being monitored. Folks, they're being monitored simply to make sure that they are indeed in parallel. They can send keep alives back and forth to each other. They're being monitored to make sure, again, they're on the same subnet and they have unique IP addresses. They're being monitored to make sure that the physical interfaces are up and running and they are accessible on the network. They can actually communicate on the network. Now, as far as the verification, I want to say it again, you can, if you're a command line person, which I strongly often am, you can do a show failover, which we're going to show you on the next slide, or you can just go back to where we were a moment ago, look at the failover pair, logical pair that has been configured, and see once again the primary and active, or if you will, the role and the state that we talked about earlier. And then I'm also able to go under the individual device and see details on that particular device. Or one more time, if you're more of a command line person, again, I'm just old school, so I naturally gravitate to the command line. I'm able to go to the command line and again do my show failover command. And please note, the service is on. This unit's role is currently primary. I see that not only the role primary, but the state is currently active. and we get a chance to see where is my peer and my peer's role and state as well. Very good information. And by the way, that's just to include the physical device role and state as I mentioned, but guys, you're also able to see any kind of interface information as well. So high level, what we went over here in this topic is that there are two ways to do availability and scalability, whether it's going to be failover or clustering. Failover again, well, first off, before I go over the cool geeky stuff, failover and clustering mechanisms are inherited from the ASA platform. So as we started this subject, if you're familiar with the ASA failover and clustering configurations, you're familiar with this as well. So again, failover allows us to put two firewalls in parallel, identical in every way, one of them be active, the other one be standby. Yes, we do have the ability to do active-active with the concept of security context or virtual firewalls, not to be confused with an ASA via firewall as a virtual machine. And then we also have clustering and our ability to cluster up to 16 physical devices, that is inter-chassis, but we can also cluster within inside of a chassis on modules. Again, the total number of modules depending upon your firewall appliance, your firepower firewall appliance. Thank you very much for listening. See you on the next topic.